Hello, we are starting on page 193. This is activity lesson 3. We're just going to be completing the getting started and activity 1 portion of this lesson. So not everything, but if we look at here, the learning goals, it says to derive the equation y equals the mx plus b. The second is use similar triangles to show the slope between varying points. And then also to use the slope formula to calculate the rate of change between 2 points on the coordinate grid. We're going to forego the review. This was just to prove that these two triangles are similar, but let's go to page 194. Okay, so for 194, we're looking at these three shapes here. Consider the three street signs. So number one, where you see each of the signs. It already says it here, so most likely it's going to be the street, but let's put for this one, instead of writing complete sentence, I'm just going to draw an arrow. The first one might be, let's say, going, you would see this as you can see the vehicle, it's going up. So let's say up a steep hill or mountain. Okay, if we look at the second one, we have one that's going down as well as the third one. So I'm just going to kind of combine these two things here. Let's just say the last two would be seen as vehicles traveling down. And we'll say traveling down a hill / mountain. I'll put MT for mountain. All right, number two. What do you know about the triangles on the slope? So there's three triangles that are formed. What can we say about all these triangles? The first thing we can say is that all are right triangles. Okay, that's one thing. Now we're not sure about these right triangles, but we could say possibly the last triangle. The last triangle. So as you can see, that there's certain percentages next to these images. Last triangle doesn't have 8%, but the last triangle could be similar to the other two. Similar to the other. I'll just put two triangles. But we can't say for sure. We're just making an assumption there. But let's go to number 3. For the signs that do include numbers, so the first and second, what do you think those numbers represent? Right, so we have a 9% and an 8%. 9% going up, 8% going down. The numbers represent, or the numbers are when you're driving on a road, you call this the grade or gradient, but we could also say or steepness of the road. Okay. Now for this, right, we'd say 9%. That's probably going to be steeper than 8%. But we'll work more on this on activity 1. So we're just moving to activity 1, which is just the next 2 pages, and that is it for this video. So a lot of our time will be trying to annotate this graph here. So to just kind of review a little bit, we've been working on proportional relationships. So those are lines that are straight lines. They go through the origin, just like this one. I'll put a point here at the origin. But not every single line or ratio represents a proportional relationship. So let's look at the context here and highlight some things that are important. It says Jack and Jill. So this represents Jack and Jill, but the context is Jack and Jill's Aunt Mary lives 10 yards from their home. Let's highlight that. From their home closer to the bus stop. And after spending Monday night at Aunt Mary's house, they leave for the bus stop from there Tuesday morning. They walk at the same rate from either house, and it's also the same rate as we worked on these other activities, 4 yards every 3 seconds. So again, to kind of summarize this, 4 yards is about the height of the classroom. It's a little bit more than that, but you're walking that distance in 3 seconds. Okay, so the graph y equal to 4/3 x is already graphed for us. It's a proportional relationship, and this represents Jack and Jill's walk from their house. Now let's just look specifically at the x and y axis. So the x axis is time in seconds that they're walking, and the y axis is distance from Jack and Jill's house. So we'll say distance, and also highlight that this is in yards. Okay, now we're gonna do some stuff with patty paper, but we're not gonna do that. I'm gonna give you some information to hopefully use, still graph this without that tool. But it says, let's graph the line to represent their walk to the bus stop from Aunt Mary's house. All right, so Aunt Mary is 10 yards away. Really what's happening here is that everything that's graphed on this blue line is going to be 10 yards further away. So that distance from Jack and Jill's house is going to be increased by 10. So B, it says translate this line to represent their walk from Aunt Mary's house, and then transfer this line onto the graph. So what you're going to do here is you're going to increase everything. We're going to, oops, let me put this. We're going to increase everything. Also, I'll put plus 10. So every single point is going to be increased plus 10. So if we start at the origin here, let's just move that up 10. This is just a transformation that we're familiar with. This is called the translation. So let's move this up 10. I'll put that here. Now we're going to graph other points. Now this point here, it might be hard to graph that, but that is 4/3 up. So that as a mixed number is 1 1/3. But let's pick a point that's a good point here. Let's pick this point here. This is the point, 3 4. So this is representing that in 3 seconds, that distance from Jack and Jill's house is 4 yards. But the thing is, we know that it's 10 yards more because we're at Aunt Mary's house. But for this, I'd like for you to move this up 10. So we're going to count from this point up 10. 1, 2, 3, 4, 5, 6, 7, 8, 9. Should be right over here for 10. Now, as best you can pause this, but let's just draw a straight line through these 2 points. And this represents Jack and Jill walking from Aunt Mary's house. They're 10 yards ahead. So we can say a couple of things about these 2 lines. These 2 lines, they will never intersect. They're parallel. Right? They both have the same exact slope or steepness. But we are going to answer some things on the next slide that relates to what we just graphed, and we'll be referring to the graph as well. So let's go to the last page, but we'll be going back and forth to this page. Let's go to 196. Number 2, analyze the translated line. A, does the new line represent a proportional or non-proportional relationship? So one of the two. This is the new line. Represents. Now, in order for it to be proportional, it's got to be a straight line. So yes. But it has to go through the origin. So it does not go through the origin. So it represents a non-proportional relationship. Okay. And then we're just going to put a brief reason why. So it does not go through the origin. Okay. Right, so proportional meaning, right, you can multiply one number on our x value to get a number on our the y value. So that is multiplying. This, you can't multiply one value to get to the x value. There's something else that's happening here. We're going to explore that on the table. So B, complete the table to show how the translation affects the coordinates of the new line. We're going to graph it here, but we're also going to, we're going to fill out the table and then look at the graph to confirm. So we have this first point. It's written as a table, so this is 0, 0. The next one is 1, 4/3. That as a mixed number is, I'll write it over. Yeah, I should write it right here. That's 1 1/3. The next one is 4 comma 3, and the last one here is 6 comma 8. But we're going to get new points because instead of y sub 1, we have the second line, and that second line is what represented by y sub 2 for second. Now, from here to here, we know that our distance from Jack and Jill's house is increased by 4 because we're further away. So what we're going to do is we're going to add 10, right? Because it's 10 yards away. So we're still going to keep the same x-axis here, or x values here, but we're going to take each y value, I'll double underline these, and just increase it by 10. I'm going to add 10. So the first one, if I take 0 plus 10, that is just 10. This gives me a new point that I use from the x value and the y value. This is going to be 0 comma 10. All right, let's use our next one, which is 4/3 or 1 1/3. Increase that by 10. So 1 1/3, well, let's add the 1 and the 10. That's 11. So this is 11 1/3. So that gives us a point, right? If we use the x and the y, that is 1 comma 11 1/3. You know what? Let's go ahead and check these 2 points. So try to remember them. 0 10, 1 11/3. 0 10. Yep, 0 10 is nowhere left and right. We just go up 10. And 1 comma 11 1/3. So 1 to the right, 11 1/3. That is just about that point right here. Yeah, because this right here is 11, and this right here is about 1/3. All right, let's go to the next one. All right, we have 4, right? 4 plus 10 is 14. Use x comma y. This is 3 comma 14, which represents, right, in 3 seconds, Jack and Jill, they are 14 yards from their house. And then, you know what, let's go to the last one. 8 plus 10. 8 plus 10 is 18. So we got 6 comma 18. Let's write that here. Okay, so let's just verify these 2 points. 3 comma 14 and 6 comma 18. So 3 14, 6 18. So 3 14, 6 8. Sorry, 3 14. 3 14. Oh, that was the point that we used here. So that is graphed. Okay, and then 6 18. So I'm going to go 6 to the right. So 6 to the right is right here. But I'm not going to put a point there. We have to go up 18. And that looks like that point's a little bit off, actually. Should be right here. And let's see if we can do a little bit better job drawing this line. Oh, you know what? I actually did graph it right. Let me erase this point. I looked at the wrong area here. So 6, if I go up, it's actually right here. All right, so never mind. We did that correctly. It has a height of 18 and a width to the right of 6. So 6 seconds, we are 18 yards away from the house. All right, anyways, so this idea right here, though, that we're adding 10, that's going to play a role. But let's go ahead and describe that. So we did say describe any patterns that you notice. What we did is we had a translation, right? We translated, we shifted this up. Translation, we're going to say adds 10 to the y value, right? Which was we added 10 to y1, which we got is y2. All right. See, how does this translation affect the unit rate? It preserves the unit rate. The unit rate is still the same. It's still 4/3 of a yard every second. So we're going to say that this preserves, meaning it stays the same, preserves the unit rate. All right, so nothing happens with the unit rate, which is our slope. Nothing happened with the slope, right? The slope is still the same. It's still the same exact steepness. All right, and then we're now going to write an equation for D. Write an equation to represent the translated line, so that one that we drew, We're going to let y sub 2 represent the distance from Jack and Jill's house, and let x represent the time spent walking, so time in seconds. Explain how this line is the same and different from this original line that we had. Y sub 1 is 4/3 x. So let's go and write the equation first. So instead of writing y sub 1, I'll put y sub 2. So y sub 2, it is 4/3 x. The 2 just represents that it's the second line. But what we did is we added 10 to this line. So what I'm just going to do, I'm going to do exactly what I said. I'm going to put plus 10. All right. Now this plus 10, I just put at the end, and this is the equation of the line. But let's go ahead and describe this. So what can we say about the rate? So the rate, we can say the rate of change, but I'll say the rate is the same. Right, I'll say the unit rate. But that just means the slope. The slope is the same. But let's go ahead and specify here is that instead of starting at the origin, we are starting the starting points. Put PT for points is 0 yards. Put YD. I'll put S. Instead of, oh sorry, is not 0 yards. It's 10 yards instead of 0. Okay. All right, good there. And then let's go ahead and finish this up. So key thing here, this is the first time you're learning about this. You have written a general rule or general equation, y equal to mx. Let's highlight that. To relate the independent and dependent variables and also the slope in a proportional relationship. Right, m represents the slope. How does this general equation change when you translate the line vertically by b units? Right, so this 10 is what moved it up 10. As like a quick hint, if you had minus 10, it would move it down 10. But number 3, write a general equation to represent the relationship of y equal to mx after it's translated vertically b units. So we're just going to write y equal to mx. If I move this b units, this will be up. It's exactly that. Instead of putting plus 10, I'm going to put plus b. So this is an equation. It's called slope-intercept form. We'll spend more time on this, but this is an equation that we're going to become very familiar with. So y equals mx plus b. All right, we're going to end the activity there. Thank you.